Hey everyone, I'm going to talk about the solution to the problem tan x greater than or equal to 3. If you follow the steps that are described in the notes, step number 1 tells you that you want to get 0 on one side of your inequality. So we're going to subtract the square root of 3 over. So we get greater than or equal to 0. So that's just because we're going to build a sign chart eventually, so we want to compare something to 0 so that our signs, positive or negative, make sense. Then step number 2 says to write this as a function. That step is there because this tells us which function to graph when we go to look at the graph to build our sign chart, and it's the function that we're building the sign chart for. Step 3, we find the zeros of the function and we find where the function is undefined. So the zeros of f, we just set the equation for the function equal to 0 to get those. So you want to add the square root of 3 back over to the other side. So you're trying to solve where is tangent equal to the square root of 3. And for this problem, we're solving within 0 to 2 pi. So what we're going to have here is x is equal to pi over 3. And 4 pi over 3. Okay, and then we also want to find out where f is undefined. And because there's a tangent in the problem, it will be undefined at certain spots. Because remember what tangent is equal to? Tangent is actually sine divided by cosine. And you know for domains, your denominator is never allowed to equal 0, right? If a denominator is equal to 0, that makes it undefined. So cosine is not allowed to equal 0. Where does cosine equal 0? At pi over 2. And at 3 pi over 2. Okay, so those are the 4 values that we're going to put on our sign chart. For this problem, we want to solve from 0 to 2 pi. So we start and stop our number line there, and we put these values in order on here. We would have pi over 3 as our smallest, then pi over 2, then 4 pi over 3, then 3 pi over 2. You can just look at your unit circle to get that order if you weren't sure. Or think about fractions, right? Okay, so now we have to decide with the values that we put on the sign chart so far, should they be included in our answer or should they not be included? So basically, should you use a parenthesis on them or a bracket when we get to our interval notation? Whatever values come from making the function undefined, you never, ever include those. So I always put an open circle on these. So I remember that I'm going to put a parenthesis. Then you look over here, these are the zeros of the function. They will be included if we're solving a problem with an equal to bar on the inequality, because we're looking for where this is greater than or equal to 0. These are the values where it equals 0. So yes, they're included. If there was no equal to bar, though, on that inequality, we would not include them. Okay, now we use the calculator to help us out. So we're going to go ahead and graph this. Let me grab my calculator. You're graphing your function. So go into y equals. Go ahead and graph tan x minus the square root of 3. We're going to have to play with our window. Let's see if it'll let me go to window. So our window should be 0 to 2 pi because that's what we're looking at. Y min, I'm going to try negative 5 to 5 for y min and y max. Graph it. Okay, so I can tell right away that that doesn't look right. That's almost a straight line. If that happens to you, it's probably because you are in degree mode when you should be in radian mode. So make sure you're in radian mode. Let's hit graph again. That looks much better. Okay, so now what you can do is look at this. you can visualize what's positive, what's negative by whether it's below or above the x-axis. See how the graph goes from below to above to below, below to above to below? So your signs are going to be negative, positive, negative, positive, negative. And I'll show you another way to figure that out, but I'm going to put these in. So I said negative, positive, negative, positive, negative. Another way we could do it is by test values. So if you hit trace, you'd have to test something smaller than pi over 3. So maybe something like pi over 6. So we type pi over 6 in. See the y value that pops out here is a negative number, so I would know to put a negative there. Then you'd have to test something between pi over 3 and pi over 2. So let's just be creative here. We'll say pi over 3 plus 0.1. So that made it a little bit bigger, right? That's a positive value. And you could keep going with this. Hold on one second. Hold on, I'll come change it for you. 1 second, okay? 1 second. All right, so then final answer. Oh, you know what? I forgot one thing. You should look at your endpoints. So the ends of the graph at 0, if you test 0, see it's a negative value. I'm going to mark that as negative as well. And then if you test 2 pi, whoops, not let me do that for some reason, but you can see that it's negative at the end there as well. All right, so what are we looking for? We're looking for greater than or equal to 0, which means positive. So we answer with our positive intervals. Rowan, please stop for 1 second. I'll come change it for you 1 second, I promise. Stop crying, please. Shh. Okay, so pi over 3 to pi over 2. Oh, geez. 4 pi over 3 to 3 pi over 2. All right, that should be your answer. Sorry about the crying.